Okay, so learning target for this. It looks like we need to find the area of a regular polygon. Regular polygon. Those have straight sides. What are they doing in a unit with circles? This will be interesting. Of course, the nice thing about a regular polygon is you know that all the sides are the same and all the angles are the same. Right? They're all congruent. If we're talking about the sides or the angles, they're all congruent. And of course, if we're talking about the sides, they're all equal in length because they're all congruent. And if we're talking about the angles, they all have to have an equal measurement because they're all congruent. Ooh, a new vocabulary word. Apothem. Ooh, that's really exciting. Apothem. Let's find out what it means. Aha. Now, not every polygon is going to have a center, but if it's a regular polygon, then there is a center, right? We can rotate it around that center. We did that earlier, a few units ago. We talked about translations and rotations and flips and all sorts of good stuff. So we know there's a center of that polygon. And so if I start at the center and I try to find the shortest route, right? Because distance is also the shortest distance. The distance from the center to any side, those are all going to be the same, and we call it the apothem. And of course, as we learned before, if you try to find the shortest distance from a point to a line or from a point to a line segment, they have to be perpendicular, right? The distance in that line segment has to be perpendicular. And of course, hexagon is not the only regular polygon, right? I've got an octagon, right? 8-sided shape. Have a nonagon, right? 9-sided shape. In each case, to get from the center of the polygon to any side, the distance, of course, will be perpendicular, and we call it the apothem. Okay, and again, what's this doing in here with all these circles? Oh, take a look at that. If it's a regular polygon, it can be inscribed in a circle. And notice that besides the apothem PQ, we can also make a triangle using the radius MP and the radius PN. And we've got a central angle. That central angle is what's going to make life really, really pleasant. Notice that the center of the regular polygon is the same as the center at the circumscribed circle. And the radius of a polygon, right, the distance from the center of the polygon to a vertex, is the same as the radius of the circle. Right, so the polygon is inscribed. That means the circle is circumscribed. So we've got an isosceles triangle there, right? Because every radius has to be congruent. So every radius has to be equal in length. So it's an isosceles triangle. And the apothem is the height of that isosceles triangle. So the base of that triangle is the side of the polygon, and then the legs that are congruent, those are radii. Now, the sweet thing about that central angle, we know all the way around the circle is 360 degrees. because the polygon has to be regular, we know that it's going to get cut into congruent pieces or equal measurement pieces. So in this case, if there's 6 sides on the polygon, 360 degrees divided by 6 will tell me how many degrees that central angle. If it was a decagon, I'd be doing 360 degrees divided by 10. If it was a heptagon, I'd be doing 360 degrees divided by 7. Right? It's just 360 degrees divided by the number of sides. And that is why we study this with circles, because that is what really, really makes the computation really swell and nifty and wonderful. Now, if I want the area of a regular polygon, I need to do 1/2 times the apothem times the perimeter. So if I know the perimeter of the polygon and I know the apothem of the polygon, I can figure out the area of the polygon. Again, this has to be a regular polygon, right? Every side has to be congruent in length. So let's look at a couple of examples here. All right, so it's in words, right? Let's find the area of a regular octagon with each side having a length of 4. Now, if you have an assignment or a worksheet or a test or whatever, and it's given to you in words, my suggestion is that before you do anything else, you draw a picture. I'm not looking for artistic perfection, but it's a regular octagon, so you know you're going to need 8 sides. So there's my regular octagon. I know each side has a length of 4. All right. Perimeter is going to be easy to figure out. 8 sides. Each side is 4. 8 times 4 gets me 32. Now the perimeter is 32. Now, what is the length of the apothem? All right, because I need to do 1/2 times the apothem times the perimeter. Well, I've got an isosceles triangle here. And the easiest thing to figure out is going to be that central angle. There are 8 sides in an octagon. So I need to do 360 degrees divided by 8, and I get 45 degrees. Now, notice I'm only looking at half of that isosceles triangle, which means I don't really want to use 45 degrees. Right? Right? I'm going to actually use half of that 45 degrees. And then, if angle A is 22.5 degrees, I know angles A and B have to add up to 90 degrees. I can figure out the measurement of angle B. Now, I know the entire side was 4, but when I'm looking at just half of that isosceles triangle, notice the base is just 2. So I know the angles. I know it's a right triangle. I know that one leg is 2. The other leg is the apothem. Well, why was I hunting for the measure of angle B? I know the tangent of angle B would be opposite over adjacent. The opposite side is AC. The adjacent side is BC. AC, we don't know because that's the apothem. BC, though, is just 2. So the tangent of 67.5 is equal to AC divided by 2. Again, where did that 67.5 come from? I know a whole circle is 360 degrees. The octagon has 8 sides, so 360 divided by 8 got me 45. But I only want to work with half of that isosceles triangle, so half of 45 gives me the 22.5. And I know the two acute angles in a right triangle have to add up to 90. So 90 subtract 22.5 is where that 67.5 came from. Of course, I can multiply both sides of my equation by 2. So AC, which is going to be my apothem, is 2 times the tangent of 67.5. When I'm using for a calculator, I've got to make sure I'm set in degrees. So I'm going to do tangent of 67.5 degrees. Get that wonderful answer, multiply by 2. I now know that AC is 4.83, which of course is now my apothem. So the area of the rectangle, 1/2 times the apothem times the perimeter. Remember from the previous slide that we figured out the perimeter was 32. So I got to do 1/2 times 4.83 times 32. Answer is pretty close to 77.25. Since I was not given any dimensions, I just have to go with square units. Okay, again, nonagon would have 9 sides. If we're lucky, there's a picture waiting for us. If not, you'd have to draw your own. Again, piece of cake would be the perimeter. There are 9 sides. Each side has length 6. 9 times 6 is 54. How about the apothem? Well, let's look at that central angle. 360 degrees would be all the way around a circle. Divide that by 9 because that nonagon has 9 sides. 360 divided by 9 gets 40. So 360 degrees divided by 9 is 40 degrees. But when I put the apothem in there, that central angle is cut in half. So 40 degrees divided by 2 is 20 degrees. And of course, it also cuts that side in half. So I don't really want to work with that 6. I want half of that, which is 3. So I've got a 20-degree angle. Of course, the apothem has to be perpendicular to the side, and so we know that's a 9-degree angle. We know half of 6 was 3. What's that other angle? Well, 70. The other angle is 70 degrees. So I know that the tangent of 70, tangent is opposite over adjacent. Opposite of that 70 degrees, of course, is the apothem. The leg that's adjacent is 3. Multiply both sides by 3. Grab a calculator, and I now know the apothem is about 8.24. Area of that polygon, 1/2 times the apothem times the perimeter. 1/2 times 8.24 times 54. Push buttons with a calculator, come up with an answer a little bit larger than 222. And we got a copy and paste error, right? The area should be 222.55. I think that 77.25 was from the previous example. Egads. Got to fix this PowerPoint also. But yeah, the answer should be 222.55 square units. Well, that's 2 PowerPoints this unit that I've got a little typographical error that I got to go back and fix. We got a third worksheet coming up. And then the IXL is actually a little bit of mixed review.